Hi, welcome to this video. My name's Phil and I'm a senior lecturer in astrophysics at the University of Lincoln, and I want to use this video to have a look at galaxies again, but also look at something that's known as kind of galactic harassment and how that can actually impact the evolution and formation basically of galaxies as we go forward. So just a recap really on galaxies. If you haven't come across them before, maybe you have, maybe you can't quite remember exactly what a galaxy is. Well, these are enormous vast systems that are comprised of stars, gas, dust, also dark matter, and they're generally held together by gravity. So some of these are kind of orbiting or they're rotating like a disk, like the one we see here, this spiral galaxy, the disk-like galaxies. Or we have more spherical ones which are not disk-like, they're kind of rounder, and they have different compositions of stars, gas, dust and all that sort of thing. But generally these are massive systems with a collection of all different matter in them. So if we go to kind of the Hubble classification system, this kind of tuning fork, they can broadly be split out into like two main groups. Now there are various other probably rarer types like dwarf galaxies, irregular, other things like that, but the two main types really are your spirals, your disk-like galaxies, and then your elliptical galaxies. So your spirals sit on the right hand side and they take these two pathways. Now there is sometimes a middle one, intermediate, but basically the top one is your normal spirals with a kind of spherical central bulge, and then the bottom one is actually referring to like a barred spiral galaxy, a bit like the Milky Way. And then actually on the other side you have your elliptical galaxies, and these ones are kind of more spherical, these are rounder, they're not disc-like, and this time around they're just kind of characterized by their shape, whereas the spirals, what happens is they can actually evolve from the right to the left. So actually as they evolve, their spirals get tighter, their gas content decreases, but most of the time the ellipticals are classified by their shape. So E0 would be quite spherical, E7 is almost like cigar shaped, although actually there's a separate video on like the E7, E6 and stuff like that, because they might not actually be elliptical galaxies after all. So two main types of galaxies that you have there. Now galaxies in general are not evenly distributed out through the galaxy, or not the galaxy, the universe I should say. They typically tend to group together in these clusters or these groups, so they're not just isolated. You do have isolated galaxies, but the vast majority of them seem to be gravitationally bound in these large clusters and these groups. So here you've got a really nice example of a cluster here, and all of those, pretty much all of those there, are individual galaxies, and they sit in these very large structures. So whilst galaxies themselves are very large structures, they make even bigger structures themselves with these clusters, and actually you get things like filaments and things like that in the universe. So if you look at universe sort of scales, the way that these galaxies are distributed through the universe, you start to get much bigger structures. So the point being is they do appear in these kind of tightly packed, gravitationally bound structures like clusters and groups. Now zooming in on some of those, they're not static, they are kind of moving around within their groups and clusters. So you have these internal dynamics, and it means they're moving relative to one another. So sometimes they actually, as they're moving, they can actually have a fairly extreme encounter. When I say extreme encounter, they basically collide, and we would refer to that as a merging event. So you've got two galaxies that collide, they then make one new larger galaxy, and actually this is thought to be part of the formation and evolution process of the bigger galaxies. So you might get some smaller galaxies that collide, you get a bigger one forming, and you end up with your elliptical galaxies, which are typically older than your disk-like galaxies. So two spirals colliding are more than likely going to create something like an elliptical large galaxy. So extreme encounters like collisions and that do occur in these clusters, but you do get weaker encounters where they don't collide. And these are known as like galactic flybys. So they're kind of flying by each other. They're not actually colliding. They're not physically interacting. But what they do is they gravitationally interact. So they actually cause gravitational tides on each other. They distort each other's shapes. So if you've got two galaxies passing by one another on a flyby event like this, they will actually gravitationally attract each other. And they will kind of distort each other. So they might become more elongated, as you can see here. They're kind of like distorting one another. Now, that's a bit kind of like how the tides are formed. So here, you've got a nice animation by NASA, and the moon's kind of going around the Earth here, and the moon causes a gravitational tide on the Earth's oceans that we can see quite well, actually. So it's the same sort of thing, really. You've got two galaxies flying by, and they create these kind of like galactic kind of bulges or even tails and streams. So they kind of like start to almost pull material away from one another, even though they don't actually collide. It's all gravitational at a distance. So they can basically distort them. And here's an example of a distorted galaxy. Now, this particular one, I'm not saying that this one has had a flyby, but it's definitely an irregular distorted galaxy. It more than likely probably had a collision with another galaxy at some point, but over time, interactions like flybys with other galaxies will distort the shape of them as well. So they'll move away from a fairly symmetric shape to a more irregular shape if they start to interact gravitationally as they fly by one another. So what this actually does is it's going to cause clouds of gas to collapse and then form stars. So spiral galaxies like the one here, like our Milky Way, a barred spiral galaxy, they have gas in them. Elliptical galaxies have very little gas content. This is mostly kind of concerning your more disk-like ones, I suppose. And if you gravitationally perturb it, it can cause large amounts of gas clouds to collapse, which then in turn form lots of stars. So it's a bit like the spiral arms. The spiral arms have a higher content of these giant molecular clouds, which then form stars. They then obviously emit their own light, and they're higher density than the rest of the galaxy. And that's why we kind of see these spiral arms. But that's a whole other story for another video. But basically what's happening here is during these flyby events, it causes gas throughout the whole galaxy, these gas clouds to collapse and form stars. So what that actually does is you get an enormous increase in the rate of star formation, even though they're not colliding. So we know from mergers of galaxies that can do the same thing, and we end up with what can be a starburst galaxy. But even just perturbations from galaxies moving past one another, it's enough to initiate these clouds to collapse and then form lots of new stars. So it can then become a starburst galaxy like this one here. Again, this one here is most likely from a merger event from two galaxies or more colliding, as opposed to a flyby. But the point is, if you look really carefully at this, it's very bright. You've got lots of blue in there. That's the bright blue young stars, massive stars. They've only just been formed. And you've got kind of like a pinky purple there. That's from ionized hydrogen, where the stars are forming. So you kind of got these kind of clouds of gas which are then back illuminated by or heated by the stars they're forming in. So you end up with a galaxy that's just had a massive increase in star formation and is known as a starburst galaxy. And these flybys can also produce those as well. And also it can cause gas stripping. So here we might refer to these as like jellyfish galaxies. There's lots of things that can do this, but flying by one another, they can gravitationally strip gas from one another. And you've got a disk-like galaxy here, and the arrows are denoting kind of like a flow of gas coming out of that galaxy. So the gas is being stripped out of the galaxy, which is going to deplete it. That's going to do the opposite thing, really. You might get stars forming in those tentacles. As you can probably see, they're quite blue. But the main galaxy itself is going to reduce down in gas content, and then you're probably going to get lower amounts of star formation at some point in its future because it's got less gas there to turn into stars. And you've got another, probably better example there. You can see that gas kind of being stripped away from the disk-like galaxy there. And again, we sometimes refer to these as jellyfish galaxies, but I suppose they look like jellyfish, they've got tentacles, but it's not really flybys as well that do this. This is just one example. Moving through a galaxy cluster, the kind of intra-cluster medium can strip it with ram pressure, but basically tidal interactions from other galaxies can also strip this gas as well. So even if those encounters are at a very large distance, if you have multiple repeated encounters, it can have a similar effect, and those effects kind of build up over time. So you get a very small tidal interaction, then you get another one, and it kind of slowly escalates and build, and you still get this kind of similar effect where you can actually increase the star formation rates from lots of much weaker interactions from much further away galaxies. So in these clusters, the way that the galaxies are behaving and interacting with one another is actually very, very important for galaxy formation and evolution theory. So understanding it is very, very important. So thank you for watching, and if you enjoy the videos and find them helpful, then do consider becoming a member of the channel. There's extra videos in the member section, but it also helps support the channel going forward. So thank you for watching.